Not really. I mean, maybe, but you'll have to earn it, obviously. Okay, so draw yourself a number line. Um, uh, I got already, good job for those of you who did, already 2 questions about question 1 on the homework. Good for starting. If you didn't start, start. Not right now. Number one starts with asking if I put the origin here versus there versus there, what is the displacement of some motion? What is the origin? What is the position for some object? And I'm going to cheat and tell you the answers here. Okay, I have sketched the start of a number line. Maybe I should make some tick marks. Sketch the start of a number line for an object. No, there is no object yet. There is no object. Here's a number line where I've identified the origin, and I'm going to start an object. Where am I going to start the object? I'm going to start the object there at x equals -1. And I'm going to say that I displace by 3 meters, positive 3 meters. Google question D, what is my final position? Again, the question is, here's initial, I'll tell you here's initial, and then I undergo displacement of 3 meters. Where do I end up? Positive direction, positive 3 meters. I should really include some numbers here. Okay, so if I start at -1 and count 3 spaces over, where do I end up? 2, not 3. My final position, if I start at -1 and add 3, -1 plus 3 is 2. Okay. So if delta x equals 3 and x initial equals -1, then x final equals 2, right there. Yeah. This is the hardest, this is the question that people are already confused about in the homework. So if this seems easy, well, maybe you're misunderestimating it. Jesus, I can't count. What's my displacement now, man? I start at 2, end at 5. Google form. If I start at 2 and end at 5, what's my displacement? Google for me, what's my displacement now? It is not 5, baby. Good. Most of y'all are putting 3 meters, and that's correct. If I start at dos and end at cinco, that is a displacement of cinco minus dos. Last I checked, that goes by the name 3. Final minus initial is 3. Does it matter where I put x equals 0? Displacement, how far and which way, doesn't care where the origin is. Merry Christmas. There's a huge hint on numero uno. What's the final position? Originally, what was the final position? Anyone remember? What is the final position now? Are those the same? No. Position does depend on the coordinate origin. If this is x height equals 0, how high is my hand? 2 meters. If this is the coordinate origin, how high is my hand? About 1 meter, yeah? Position depends on where you set x equals 0. But if my hand is moving downward, I have displaced from 1 to 0, from 2 to 1. I've displaced the same -1 meter either way. If you struggle with questions 1 or 2 on the homework, draw a freaking number line, label things, and think about what it means to have a final, initial, position, or a displacement. Okay. Got that? Is good? I want to hit this again real fast. Find the slope at time 10 seconds. Don't look at your notes. Real fast. Find the slope at time. No. First, I want to do a differenter. Find the slope at time t equals 22 seconds. Let me hold up 22 fingers here. Google question F. Find the slope at time t equals 22. Ready, set, go. Yeah, Google form F. What's the slope at time t equals 22? Do this individually. No spoilers for the people around you. I want to see how many people this clocks with. Again, the slope of the graph at time t equals 22. Use the equation we have for slope. And this goes in F, not G, darn it. Put it in F, not G. I'm pleased, muchly pleased. So far, there are 5 mistakes. In the 3 o'clock class, it was about 30 mistakes. Oh, here are the mistakes trailing in. Womp womp. Okay, 10% of you. Okay. I'd like this to be 0% of you. Rise over run. Is this line rising? He flat, man. He flat. Okay, interpret this graph. At time t equals 20 seconds, where am I? 100. Say this is position 100. At time t equals 21 seconds, where am I? Read the graph. 100. Time t equals 23 seconds, where am I? Am I moving? Do not divide 100 divided by 22. No work. The slope formula is as follows. I should have written the answer. Equivalently, you will also see me write. Change in vertical coordinate over change in horizontal coordinate. I pick 2 points on here and I say, what is the difference in the vertical coordinate between 100 and 100? 0! The rise is 0. y2 minus y1 is 0. Slope is 0. My velocity is 0. Okay? Question G, real fast, quick like a bunny, find the slope at time 15 seconds. Question G, find the slope at time 15 seconds. You can interpolate. If you need. Bunch of correct answers. Don't look at your previous notes, by the way, and no hinty for each other. I want to see who's getting this right on your own. There will be a bunch of group work, but not right now. Again, the question, la pregunta, is, die Fragen is at time t equals 15 seconds, what is the velocity? Find the velocity of the child whose graph is shown at 15 seconds. Okay, 5 seconds. Chop chop. Okay, my friends, half of you are still screwing up the formula. I have at this count 44, wait, a third of you. I can divide. Yeah. Division problem on both sides. Okay. Third of you are still messing this up. I will give one more shot at explaining. Thou shalt freaking go to Khan freaking Academy, thine math teacher, a math tutor, or someone to fix this. If you cannot slope, you will end up failing or barely squeaking by in this class. Thou shalt know slope. You have to be able to calculate this, okay? For real, I mean it this time. I'm going to give one more shot at it, but please, if you did not say 2.5, seek serious tutorage or something. Here's how I do this. I take 82.5 and divide it by 15. No! That's y over x. No, don't do that. Don't do that. It is not the y coordinate divided by the x coordinate. That's a thing. That's the slope of, for dog's sake, that's the slope of that line, the line that connects the origin with that point. But that's not the object, that's not the way this object is moving. Okay, I'm going to show you one way to calculate this rise over run. Pick any 2 points along this line. I pick 0, 50 and 1582.5. Huh? I could also pick 2100 or 1075. It doesn't matter. You got the same slope anywhere, but I'll pick these 2 points for shits and giggles. Okay? What does the rise even mean? Change in y. What does that mean? How much up does the graph go? From 50 to 82.5. Rise is not 82.5. It's 32.5. The change in the vertical coordinate. Am I doing that subtraction right? Yeah, right? Yeah, right? Please tell me, yeah? Yeah? Good. What's the run? Run, run, do not walk. 15 from 0 to 15. That's the horizontal change. x2 minus x1. Yeah. So what is my slopey? Rise over run works out to be 2.5 meters per second. Now, as I said, 1/3 of the class is not calculating this. Please turn to both of your neighbors and argue about why the hell this is 2.5 or not 2.5. Explain to each other and then ask me a question that lets me help you. Also, it's sleepy time in here. Let's turn on some lights so it's not so sleepy time, okay? Tres, dos, uno. Wait, hold on. Wait, hold on. Hold on. No, 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 you don't. Hold on. I'm thinking to myself. Shush, Ross, not shush you. Yeah, yeah. Okay. I can't average two numbers apparently. Thank you. Now question me. You don't have to admit to anybody that you don't understand this. Pretend that your classmate screwed it up. Tell me what they were screwed about. Questions. Tell me where you might imagine somebody might be confused. No one can even imagine where a point of confusion might be. Only 2/3 of you got this right, yeah?
I just kind of guessed, oh, that looks like it'd be like 80. And because I was like, I didn't think about doing 100 minus 75, finding the middle.
Oh. Oh. You're fine. I mean, be more careful next time, but sure. That's not a deep concept mistake that I think is screwing most of the people up. Yeah. That is probably a way better way to do it. That's what I demonstrated last time. But I wanted to emphasize that at time 15, you can use that number, just got to be more careful about it. Yes, so to hit on this, I mean, I am married, but I'm going to hit on this anyway. You got a straight line, straighter than me even, straight line between 0 and 20 seconds. So rise here. How far have I risen? 50. How far have I run? 50 over 20 is 2.5. Bam, velocity 2.5 meters per second. That's a way better way of doing it. Smoother. But people who got 8 as the slope, we're not doing. No problem. No? Yes? Oui? No? Okay, so real fast, also, let's review what graphically do we interpret as various thingy things on a position graph. We're going to be talking about velocity graphs towards the end of this, and the interpretation is totally different. So I want to think about this and reason through this so it's not memorize stuff. Memorize physics, oh my God, you'll confuse everything for everything else, you'll fail. Don't memorize. Don't memorize anything but definitions and core equations. Don't memorize answers. I'll screw you up. So let's interpret. What does it mean to be close to the horizontal axis versus far from the horizontal axis? What does that tell you on a position graph? Distance from what? From the origin. Not the starting point. Looky, looky, looky. Here's the starting point. You start at 50. That's far away from 0. Distance from origin. Okay, so whether you're close to axis or far from axis isn't close to starting or far from starting. It's close to wherever you decided to call x equals 0. What does it mean for the slope of velocity, for the slope of position to be positive versus negative? That's on a velocity graph. If you have a steady slope, then your velocity ain't changing. What do you think? That's if your positions are above the horizontal axis, if your position numbers are positive, then you are above. If your position numbers are negative, then you are below, where you are at. That's actually worth knowing and writing and reviewing. If your position numbers are far from zero, either positive or negative direction, that tells you are far from wherever you've called the origin. If your position values are positive numbers, that tells you you are, in our usual example, most common example, you are above origin. If your position numbers are below origin, that tells you you are below your origin if they're negative positions. What if your slope is positive? What does slope tell us? Velocity. Slope of position is velocity. Know that. Slope of position is velocity. What does it mean to have a positive velocity? That's if you're talking about a velocity graph. Steady slope means steady velocity, neither speeding nor slowing. What do you think? Your speed is constant if you've got a constant slope, but what about just the fact that slope is up versus down? What quality of motion, describe it like I'm 5, is that? The direction of what? What do you mean the direction of the object? What's my direction? I don't have a direction. The direction of the... You guys are so close, so damn close. You are moving forward. You're moving in the positive direction. If your slope is positive, if your velocity is positive, your positions are increasing. Now I want to quibble. There's a second thing that says, that makes you think increasing positions get further from zero, right? Yeah, does that make sense? If you increase your position, you get away from zero? No. What if your position is -3? What's bigger than -3? -2. -2 is further to the right on the number line. What's bigger than -2? 0. That's bigger than 0 is greater than -2, right? On the number line, 0 is above number 2, -2. So I have increased my position, coming closer to the origin. Beware. Increasing x does not mean increasing absolute value of x. This is not an increase. This is an increase. This is an increase. So what can we say? In the usual coordinate system, table is 0. This is positive direction, positive slope of position, positive velocity. I am moving upward. Write that down. Nobody fully got that out loud, so I'm guessing that didn't click last time. Sign of velocity, just like sign of displacement, tells you the direction of motion, upward or downward, northward or southward, rightward or leftward, whatever it may be. Positive velocity, positive slope of position, tells you that you are moving in the positive direction. From time A to time B, what's the average slope of this graph? Positive or negative? Positive. Am I increasing my x's or decreasing them? I'm moving in the positive direction. From time B to time D, am I increasing or decreasing my x values? Decreasing. Is my slope average velocity of this positive or negative? From time D to time F, am I going towards or away from the origin? Is my velocity positive or negative then? Good, I didn't trick you. I thought people would say positive because they confused going away from, very common, going away from with positive speed. No, slope is negative, velocity is negative, but if I'm negative and decreasing, I'm getting negative and negativer and negativer. I am still moving downward. The average velocity from time d to time f is negative. I am moving in the negative, downward, whatever direction. Hey, how fast am I moving at time f? How would I calculate that? What would I do? Take the slope. What is the slope? Am I moving? No way, Jose. Am I moving fast or slow at D compared to, say, E? At this instant? Fast or where? I have slowed down here. Here's changing speed. If you have a curved line, a curved graph, my slope is steep, my slope is shallow. Sketch a line that is, you can zoom way the heck in, if you wish. Zoom, oh, for dog's sake. Zoom way the heck in and sketch a line whose slope looks like that. The instantaneous velocity, what your car's speedometer, if you had a velocityometer, would say is just at a given instant is just the averaged distance over a small time interval. Calculus people, shut up. Likewise, zoom way into E, and I think the slope here looks something like that. Now, is the slope at D or E more intense? D is more intense. Intensity of slope, intensity of velocity, what is that? Speed. So if I'm intenser, I'm faster. If I'm shallower, I'm slower. From D to E, I slow down. Write this down. Speeding up or slowing down on a position graph looks like curves. This is going to be on your homework, I think. If the curve takes me closer to horizontal, if I am shallowing my slope, that's slowing down. That's what slowing down looks like. From A to B, am I slowing down or speeding up? Slowing down. I am steep. I am shallow. Oh my God, I'm so shallow. Right? I'm going from fast to slow. From time B to time C, am I speeding up or slowing down? I'm going from horizontal, no motion at that instant, to speeding up, increasing the steepness. Hey, which direction am I moving at A again? Positive. Which direction am I moving at C again? Negative direction. The sign of the slope, the plus or minus of the velocity on a position graph tells you the direction of motion. Yeah? Saying this multiple times. Hey, what's happening at B? What are you doing? Are you moving? No. Which direction were you moving? Which direction are you about to start moving? How would you describe that to a 5-year-old? I was moving up, then blank happened, now I'm moving down. I turned. Exactly. Where I pass through zero velocity and change from positive to negative, or vice versa, that's a turning point. Good. Okay. Please, question me. Yes. At even an instant, if you pass through having a horizontal slope, at that instant, the slope is not up, the slope is not down, the slope is at that instant, horizontal, zoom way in, see it. Yes, not moving at that instant. That's a turnaround. Having an instantaneous zero is not always turning around. If the slope was positive and it's about to be negative, that's a turnaround at the instant it's zero. Okay, anyway, no, let's build up displacement to average velocity. Here are a couple of homework problem hints. Merry Christmas. I'm going to give you what you need. I'm going to make sure that you've got what you need to go from the theory that I've been giving you to the practical, actually do the problems in the homework and on the quiz and on the exams for that matter. Ready, set, go. This will be question H and I. Chop, chop. Draw it if you're not sure. Draw a freaking number line if you're not sure. And this now you can do together. Everything else for the rest of the day, you can talk to each other. In 25-ish minutes, we're going to see slope of velocity is speeding up or slowing down. Yeah. Well, we're not going to call it by its formal name yet, but it's not position time slope. Position time slope is just, are you moving? And which way? So watch out for that. Of course. Thank you for engaging in the freaking class. One minute. Let me remind you, you got to put something. If you have no clue, tell me where you're stuck. Oh my.
Am I supposed to like subtract the to this place or
So if I displace forward 5 and then I displace forward 5, does that mean that I haven't displaced? If I move forward 5 and then move forward another 5, I've moved 10. It's not subtraction. Huh?
just add
Draw a number line. 2. Draw a number line with each individual. Okay, time's up. Take a big breath. Take a big breath. If you are struggling here, take a big breath. This is addition and subtraction. You can do this, I swear you. If you can't do addition and subtraction, you got bigger problems than physics. Okay, so I'm going to remind you, if and this is on the struggle bus, draw a number line. Let me sketch one out. X equals 0 here, 5, 10, 15, 20, I guess. I can 25. I'm going to start NALO here. Here's my very initial. Where do I move? I move 5 meters. Which way do I move? Here's at time 1. I have displaced delta x equals 5 meters. Great. Where do I end up after the second displacement? I go 15 meters left. (25 minus 15 is so far so good. Final position, I end up at 10 meters. I could algebraically do this if I said x initial equals 20. Delta x1 means well, there's no final and initial here. This is, I guess, the middle value minus x initial equals 5. Delta x2 means x actual final minus where I started the second displacement of negative 15. I can plugga in a solva, and I would get x final equals 10 if you prefer that. Frankly, bleh. You can do it if and you like. Wait, what? You want to see it? I think it's easier to calculate position, final position first. Yeah. No. Let's say find xf. Okay. Now, total displacement. What's the total displacement? It's not it's not 30. It's not 30. It's negative 10. How do you do displacement? Delta x equals final minus initial. Where does he end up? Where does he start? Bam, negative 10 meters. The answers for H and I should be negative 10 and positive 10, respectively. Question? How's the question? Wait, say that again? The questions are 25 and negative 15. The question statements numbers are 25 then negative 15. What? So what thing I did was I started at 20 meters and I went in the negative direction at 5 meters and then in the negative direction at minus 15. So what it means to have a displacement being positive is you're moving in the positive direction. You're increasing your number. Final minus initial. Final minus what equals, sorry, final minus 20 equals 5. What can I subtract 20 from and get 5? 25 minus 20 is 5. Okay, so write it out. I shouldn't say math. Delta x was 5 meters. Delta x means final minus initial, and I told you initial is 20, yeah? Solve for xf. What do you do? How do you get that 20 away? Add 20 to both sides. If I get 5 equals x minus 20, yeah? Yeah, okay, good. Okay, last chance for questions about displacement. I want to emphasize again, by the way, also yes, 2, total displacement is not 20. He might walk 20 meters. That is different from his displacement. If I walk a meter and walk a meter back, I have indeed stepped 2 meters worth. My displacement is 0. I ended at my starting point. Question? Tell me. Yes. You may always add displacements. That is mathematically identical to what happened. If I displace in one sense, then I displace in another sense. The total is the sum of the displacements. That's totally legal. Anyone else do it that way? Added the displacements to get the total? Good. Okay, here we go. What are we on? JKL? You guys know how Harry Potter gets down a hill? Do you guys know? Walking. JK, rolling. Anyway, here we go. Read carefully, by the way. Read carefully. 2/3 of my class, the 3 o'clock section, screwed up one of these. Read carefully. God damn it. Thank you. First, they pointed that out too, but I deleted the. Thank you. JKL. What? Not this. Yeah, right. I can read. Help each other, please.
Two things. One, I accidentally, so I don't know why I didn't know this, but I have been submitting like them all on one. I just literally submitted because the girl next to me was like, should be one per response.
If I ask 3 questions, you put 3 together and hit submit, that's okay.
Okay, but I've been doing it A, B, C, D, all the way to I.
Yeah, so I want you. Yeah, that's what I'm saying. Like, so for these 3, are you putting them in JK and L?
I am, but I actually have a question about that. So, I know you're probably gonna explain this, but I'm just curious.
Go on.
So if he starts at 20 and is displaced 5 meters, he's at 25. So for the equation, so would 25 be y2 and then 20 would be, yeah,
Good,
yeah?
perfect.
And then x is,
Time.
okay.
I mean, wait, the x up there or x in the slope equation? Yeah, time. Change in time.
For the last one, I got. But honestly, I think. Yes. I actually, hold on, I got the too, because I did it. Yeah, I did it in my head and I had it. I don't know, my mind used to, yeah, in my head. Yeah, thinking from your breath, but sometimes I lose.
Oh my God, people are correcting and getting righter. Oh, that makes me happy. Just love it when you get things right. It's like learning is happening. Okay, 2 minutes, and I want you to at least get J and K at all possible, please. Okay, hit enter. Submit response, please. I want statistics. I'm gonna assume you don't have any clue what's going on if I don't see responses. Or that you're asleep. Okay, so right now, as of right now, I got that 2/3 of you were able to calculate the velocity for J. Let's boost that. Let's boost that. How do I calculate velocity? What is the velocity formula? Rise over run, I don't have a graph here, do I? Distance, to be precise, displacement over time, exactly. Velocity is how much does your position change divided by how long does it take to do that? If I'm talking about the first trip, he goes from 20, displaces by 5. What's my displacement? 5. I just told you the displacement is 5. The displacement is 5. Right? Delta x is 5. If I tell you delta x equals 5. Great. How long does he take to do that? Bam. What's 5/10? 0.5 last time I checked. A third of the class wasn't able to get here. Don't freak me out. Okay, question me. Where are you getting stuck? I think where most people who are stuck are getting stuck is they're doing the same damn x over t thing. It's not where you are divided by when you are. It's how you change position. I start at 20 meters. That doesn't mean that I go 20 more. If I sit in my car and go 0 miles an hour and sit 100 miles an hour, whatever, no. I'm not going to make 15,000 analogies here. Okay, numero dos. And here's where 2/3 of the 3 o'clock section stumbled. How far do you go? How far in which way? What's your displacement? 15? Negative 15. Negative 15 meters. I tell you, displacement is negative 15 meters. How long does it take? 5 seconds. Good. Correct answer is negative 3 meters per second. Why is it 5? He said 15 there. T is not delta T. Read carefully. By the time my clock says 15 seconds, I have gone there. By the time my clock said 10 seconds, I have done the first displacement. T is not the change in time, is not the run, is not the time interval. How long does it take is not what your stopwatch is necessarily, not what your wristwatch is saying. It's the difference in two times. So time T for the second one is half. Blah, 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 negative 5. Now, what's the average of half and negative 3? Something like negative 1.5, right? We just average two numbers? No. No, 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 no. Who's heard of a weighted average? Really? Only a couple people have heard of weighted averages? Weighted average? Okay, okay. You can add average velocities that go over different time intervals if you use the weighted average. For the 90% of you who haven't apparently taken stats. Really? I thought all your majors require stats. No? Oh, okay. Doing it right now. Okay. You haven't reached there yet. Okay. So for the 90% of you who haven't reached there yet, let me tell you a story. For you guys, I would walk 500 miles. But I would not walk 500 more. I would take a subsonic jet, though, or a subsonic spacecraft there. Let's pretend I walk 500 miles. And then I jet 500 more. Let's say the first time takes me 10 hours to walk 500 miles. No, well, whatever, screw it, whatever. I would walk 500 miles, say it takes 10 hours. Subsonic jet takes basically nothing, right? Right. So how far do I go? 1,000 miles. I would walk 500 and then I would jet 500 more. 1,000 miles, how long does it take basically? 10 hours. What's the average? What's the average? I would go 1,000 miles in 10 hours. 100 miles an hour, right? 100 miles per hour. What's the average of a really freaking huge, sorry, yeah, the velocity, initial velocity is what? What did I say? What did I just say? Initial velocity is like 100, right? No. What did I just say? 500 miles, 50. Didn't I say? Yeah, I said 500 miles in 10 hours. So that's what, 50 miles an hour? What's the average of 50 miles an hour and a squillion miles an hour? 50 plus orbital speeds divided by 2 is really freaking fast. It's certainly not 100 miles an hour. Why not? Why can't you just average the two? Because the denominators of the two fractions are different. If I average two velocities, unless I've got that they're the same time intervals, you're screwed. To take an average velocity, always do unless you know what weighted averages are. Then if you do know what weighted averages are, weight by the time. Average velocity for the whole trip is total displacement, which is, what did I say? Last slide? Divided by the total time, which is no? Yes? Da, comrades? Igen? See? Hui? Da 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 da? Question me. How far did I displace? I moved 5 meters, then I moved negative 15 meters. My total displacement, negative 10. Huh? Okay. So not just the average of the two velocities. You can't do that unless you know that they happen for equal times. Negative 2/3. So what? Okay. Sketch a position time graph. You can't enter this in the Google form. I don't see how you could possibly. So just on your paper with your classmates, sketch a graph of position time. We'll do velocity in a second. Don't look up here. Maybe I should have led with having you do the graph. And I can, next year. Aw, shucks. Sorry. I'll be nicer in the future. Ha! That's a lie. Hey, Tallahassan14 at iCloud.com. You have to log in with your ASU ID. You're not going to get grade points if I can't link you, unless that's your ASU ID name. Do not log in with personal emails. It's gotta be yasu.edu. Please. Go ahead and edit form and make a new, or submit a new form for you. Don't do that in general, but likewise, Nunez0601 at Gmail, please relog in as, submit new form as your ASU. Otherwise, I won't know who to give the points to. I'll just give them to him. Would you mind? Just taking the free points. Likewise, winuangp at Gmail. Gotta be your ASU, like I said. Okay, so here we go. Here's a graph of position versus time. Hey, looky, slopey, slopey, positive, small, slopey, slopey, steepy, negative. I started fast and slow. Started slow in the positive direction, moving away, moving in the positive displacement. And then I went fast, bigger velocity, bigger slope in the negative direction, negative slope. Question. Did you get this? Okay, now here does that make a graph of velocity versus time. You're going to need this on the homework. And we're going to be doing butt tons of this next week. That's tilty. I regret my decisions. To make a graph of anything at all, ever, even the slightest bit, put the values for that thing as the heights on the graph. So for instance, what's my initial velocity? 0.5 meters per second, ringo bingo. How long does that happen? Does that change? No, not. Does that change over the course of those 10 seconds? No way, Josue. Oh, come on. Straight line. Bam, there's the first part of my graph. Bam, there's the second part of my graph. And guide the eye. There's how to draw a velocity time graph. It's going to get harder than this. Don't worry. Here's your first velocity time graph. Oh, it's baby's first velocity time graph. Put it in the picture book. Question me. So many faces don't like this. Or so many faces are just dead right now. Don't die. You're not going to learn unless you engage. Please don't die. Also because I haven't had a fatality in like 5 years in this class.
So is that line 0 velocity or?
0.5. This is 1, this is 0. Here's 0.5. Just guides the eye. There is no vertical. It's impossible to have a vertical line in a graph.
Going down.
The slope here is discontinuous. An instant before 10 seconds, it's positive half. An instant after 10 seconds, it's -3. At that instant, there is no defined slope. It is not a differentiable function. Last chance for questions about this. Okay, I want to talk about VT graphs for a hot second. This is going to be huge going into next week. After Labor Day, we've got more class. Yeah, question me. There is no answer to that. You've got a non-differentiable function. I would never ask that because it has no answer. Not well defined. Okay, so let's talk about velocity graphs. Again, position graphs. Far from origin, wherever that may be. Close to origin, wherever that may be. Moving in the positive direction, moving in the negative direction, right? Moving quickly, moving slowly. You got that? Velocity is not position, and interpreting the graph is completely different. Write this down and think about it. If my V numbers are big, what does that tell you? Move fast. If my V numbers are getting bigger, or I should say further from the horizontal axis, my V is going away from horizontal axis, what does that tell you? You are speeding up. Say speeding up. Acceleration is, we're going to define that later, and it's not what you think. If the V numbers, the velocity values, are approaching the horizontal axis, what does that tell you about the motion? Velocity was 5, now it's 4, now it's 3. What is that? What is decreasing? Speed is decreasing, it is slowing down. Those are two good ways to say it. What does it mean? What does it mean? What does it mean if velocity has a horizontal graph? What is consistent? The speed is steady, and direction. Speed and direction are steady. It is moving uniformly. It is neither speeding up nor slowing down. To summarize here, fast, slow, at rest. Speeding up, slowing down. What does it mean if the V values are in the first quadrant here, in the top, in the positives, V's? What does that tell you? Direction of what? The direction you're moving. Positive velocities tell you you're moving upward, northward, whatever. Direction of motion. Direction of motion in the positive direction. Direction of motion in the negative direction. Right? What does it mean to have positive positions? You're above the table. What does it mean to have positive velocities? You're moving upward. You can move upward while being below or above the table. What does it mean if you have a curve, a change in slope on a position graph? I told you this earlier, remember? At the instant you pass through 0, you are turning. In general, what slope tell you? Slope tells you, slope of position graph tells you velocity. What does it mean? How would we describe in ordinary words if your velocity is changing? A curve says changing slope, changing velocity. You're speeding up or slowing down, depending on whether the curvature is cuppy or down cuppy. Okay. What does it mean if you have a slope on a velocity graph? Steep slope, shallow slope. the speed is changing just if there is a non-zero slope. If you have a steep slope, it's changing rapidly. If you have a shallow slope, it means you drive my car and it takes forever to get to 65 miles an hour. You're changing your velocity slowly. So steep versus shallow on here, are you speeding up rapidly or speeding up slowly? Here, are you moving fast? Here, are you accelerating rapidly? We'll get to acceleration later. You're writing all this down, yeah? Right? Yeah? Sketch a graph, or axes anyway, and label these parts of the graph. I will absolutely, positively test on this. This is huge. And not just test on this, we're going to build on this. We're going to go places with this. You need this. Talked about. Velocity time graph. I start at 12 meters per second, positive 12 meters per second, and decrease. What's happening to my motion? Slowing down while moving in which direction? No, positive. Positive velocities mean I'm moving, for instance, up. Positive 12, positive 8, positive 4. Those are positive velocities. I'm moving upward and slowing down. Remember? Upward, downward. Fast, slow. If I am fast and moving slower, that means I'm slowing down, but I'm moving upward. The values up until time 3 is I'm positive velocities moving upward or forward or northward or whatever. Okay? I am slowing down while still moving in the positive direction. I am temporarily at a rest, turning around. I am speeding up while moving in the negative direction. It's a lot, but you now have everything you need to do this week's homeworks, this week's quiz, and this week's knowing that I love you. Get out of here. Adios. I'll answer questions if you want, but you are dismissed.